Sorry, someone is saying something. Shall I proceed?
Yes,
Yeah.
please.
Yeah, thank you, ma'am. Just a minute. I am filling my screen for everyone so that you would be able to easily see my screen. Okay, so we are starting with today's agenda. Yesterday, I told you that today I am going to firstly talk about the paired sample t-test, which we have not covered yesterday, that I'm going to cover today. And then I'll explain you the ANOVA, right? So let me share my screen first. Fine. So friends, I think I shared my screen. I hope it is visible to everyone. Okay, I'm sharing these slides firstly, which is based on the paired sample status. I want your confirmation whether these are visible to you.
Yes, ma'am, it's visible.
Yeah. So
Yes,
friends,
ma'am.
okay, thank you so much. So in continuation to the yesterday's session, where I have discussed this t-test, that is one sample and two samples. So I think I do not need to mention this, that why we are using t-test. Every one of us is now knowing that t-test is used for finding the significant mean difference, right? Now, in the case of two samples t-test, yesterday we have seen independent samples t-test. In the continuation to that, today I am going to dependent samples t-test. The other name for the same is paired samples t-test. Now, what is paired samples t-test? I think yesterday I have given you the conceptual clarity about this, but still I am mentioning today as well, as I'm covering this today. So when I talk about paired samples t-test or dependent samples t-test, here there will be the dependency of the sample, right? That means I told you yesterday we will be having only one variable, we will be having only one sample. And for the same sample or for the same variable or for the single variable or single sample, we are collecting data twice. So that way there will be a case of before and after kind of thing, or pre and post kind of situation will be there. That means there will be a time gap when you are conducting or collecting the data twice for the same sample or for the same variable, right? So this way we can say the basic requirement of the paired sample t-test is that we will be having single variable, which we can say will be the numeric variable, right? And we will collect the numerical variable data twice for the same sample, right? For example, a company is plan to give training to the employees. So company has taken their performance at the present stage. After that, company has given the training to the employees, and then after the training, after a certain period of time, again company will collect the performances of the employees, right? And that way company can make the comparison whether the significant difference is coming in the performances or not. Similarly, our teacher can also do the same. Teacher can teach in a class. Before teaching a particular topic, teacher can take the scores or the understanding or the knowledge, or we can check the knowledge of the students. And then after teaching, again, we can check whether there is any improvement in the knowledge of the students or not. So these can be the cases of paired samples t-test, right? Talking about the assumptions of paired samples t-test. So here you can see we are having three assumptions. The first one is based on, it says the dependent variable is continuous and it is measured twice on the same sample of subjects, right? So I don't think so I need to elaborate this. I have already discussed this thing, right? Coming to the second or the assumption, which says the differences between the scores of variables are normally distributed. So here you need to pay attention rather than finding or checking the normality of the variable. What we are doing here, we are saying the differences between the scores. So whatever are the two scores available, we need to take the difference of them, and then we need to check the normality of that difference, right? Then the differences between the scores of variables do not present any significant outliers. So we need to see whatever the difference we are taking of these scores, we need to see through the box plot whether there is any significant outliers is existing in that difference or not. So this way, these are the three assumptions which you need to check. I think again, you can understand the first assumption you can check by your own. You need to be careful while collecting the data that you are collecting the data for the numeric variable, right? And the remaining two we can check using the SPSS. Now, in case of the paired sample t-test, what will be the hypothesis? So generally we can say the mean difference between the variables scores is equal to 0, or there is no significant difference in the scores of variable before and after condition or situation, right? And opposite to this, you can also write the alternative hypothesis. Then usually I think this is for applying when we are asking, some of the people are having the curiosity as we are getting so many outputs in the SPSS. So what we need to report? So what we need to report, generally we can report the test value, that is the t value. We can report the degrees of freedom, p value, mean difference, and lastly the confidence interval of difference. These things can be reported by us, right? Clear? I hope
Yes.
fine here. So this was the conceptual clarity from my side for the paired sample t-test. Now, before starting with the ANOVA, I think we can go with the file which I have given to you. I think today I have given you the file named as math test. Yeah, you need to open the file. And once you are ready, please tell me so that we can proceed. Yeah, are you people ready?
Ready, ma'am.
Yes, ma'am.
Fine, thank you. So friends, you can see here in this particular file, there are 4 columns. We can say 4 variables, grade 1, grade 2, before and after. So I will tell you the paired samples t-test on the grade 1 and grade 2. The remaining pair you can use for your own practice purpose, right? So suppose the first situation where we are having the grade 1 and grade 2, we can say we are having the scores of the students. We can check how many students are mentioned. I think total of 359. So we are having these grades or the scores of the 359 students before teaching them a particular topic and after teaching them a particular topic. We want to see whether there is a significant difference existing in the grades, right? So we can formulate the hypothesis like there is no significant difference in the mean grade 1 and grade 2 before teaching and after teaching. This can be the hypothesis. I hope hypothesis is clear.
Yes.
And we can see we are having a single variable available here, that is grade. Only we have named it as a grade 1 and grade 2 so that we can differentiate that twice we have collected the grades, right? Second thing is the grades which we have collected from the respondents. So we can I can say this to you people that this is the data of the same 359 people for which I have collected the data for under the grade 1, and for the same people we have collected the data for the grade 2, right? Now, as per the assumptions, first I think it is clear we are having the numeric variable available which we are treating as a dependent variable. Next is to check the normality assumption and to check the outliers assumption. We need to firstly take the difference, right? So I request you go to the transform tab, and then from this you can find there is a first option available named as compute variable. So if you have found this option, you can click on this. Repeating again, transform, then compute variable. Done? Shall I go ahead?
Yes, sir.
Yeah. So you can find a pop-up is appearing for the compute variable, where you can observe one thing, that the cursor is blinking on the target variable box. That means it is asking you to give the name to your variable. Means as we are computing a variable, so I need to give the name to my variable. So I am giving the name as difference, because I am going to calculate the difference here, right? So after giving the name to the variable, what you need to do next, I'll tell you. First, you will tell me you have written or given the name to your target variable. Done?
Yes, ma'am.
Yes. Now, as we need to get the difference, you can also see we are having here the calculator. So it is not tough for us to calculate the difference. So you can shift, you can select grade 1 and shift it into the numeric expression box using the arrow key. Then from the calculator keys, you can select the subtraction, that is minus symbol, and then you can shift grade 2 in the numeric expression box after the minus. Then I think very simple, right?
Yes.
Now click
Yes.
on OK. Yeah. So click on OK. You will be sent on the output where you can come to your original data, and you can see now one more column is added to your data view named as difference. I hope it is visible and you will have also obtained the same.
Yes.
Yes.
Yes, ma'am.
You can go to the variable view. You can check difference is numeric. As the values are numeric, SPSS has already taken its type as numeric and set its measure as scale. So these two things is already set by SPSS. Now coming back to the data. So we need to now check the assumptions. So can anyone tell me, for checking the two assumptions, that is normality and outliers, what I need to do?
Shapiro will test.
Okay, so where I need to go? Can anyone guide me? I think we have done these things. Where we need to go for checking the
Analyze the descriptive statistics, then explore.
very good. May I know the name? Who is speaking?
Ma'am, it's Pooja Bahugna, Dr. Pooja Bahugna.
Pooja ma'am. Thank you so much, Pooja ma'am. Ma'am is very correct. We need to go to the analyze, descriptive statistics, and explore. So I'm clicking on the explore now. So we can see we are having the explore box in front of us. As we are very clear, we need to check the normality assumption and the outliers assumption for the difference. So you need to select it and shift it into the dependent list box. After shifting, you can click on the plots. I am selecting the stem and leaf, selecting histogram and the normality plots with tests. So this is what you need to do. After doing this, you can press on continue. So tell me, shall I go ahead?
Yes, ma'am.
Yes.
Yeah. Now click on the OK. Yeah, so you can see we are getting in the output viewer the output of the what we have performed just now, that is descriptive statistics. So you can find first is the summary table, which is telling you we are having total 359 respondents data for the difference, right? And there is no missing value. So the total is 359. Next comes the descriptive statistics. So I think yesterday itself we have discussed this. Before also we have discussed this. We need to pay major attention on the skewness in the kurtosis value. Looking at the skewness, you can see it is 0.243, which is not a very big value, but still it is a positive value, right? Kurtosis is again a small figure, minus 0.63. It is a negative value. Now coming down and looking at the test of normality. Look at the value of Shapirovil's test, significant of p-value. Once you will look at this, I hope it is quite clear. The p-value or the significant value is greater than 0.05, right? So when it is greater than 0.05, what inferences I can draw or what I can conclude?
That we
Ma'am,
hold on to the
have
null
accept
hypothesis.
the null
We are
hypothesis.
holding the null hypothesis. Very correct. And what was the null hypothesis of Shapiro-Wilks?
That the mean of the two grade, the difference of the mean of two grade was not very different.
No, it's related to normality, ma'am.
Okay.
And I think I told you to note down. Yes. Yes, anyone? I told you, I think yesterday also and before also I told you the hypothesis for the Shapiro or the Kolmogorov. For both these tests, the hypothesis is variable is normally distributed. And just you said that we need to hold the null hypothesis. So what we can say, the difference which we have calculated is normally distributed. I hope it is clear.
Yes, sir.
Yeah. Going down, you can see the histogram. Almost we can say it is not exactly, but little bit tending towards the normal. We can double click. We can put a distribution curve on it. We can close it. We can close this window and we can see. So I hope you can see it is a approximately normally distributed difference value or difference distribution, right? The difference which we have calculated, its distribution is approximately normally distributed. Yes or no?
Yes, sir.
Yes, ma'am.
Now, looking at the QQ plot, you can find there is some of the departures for the difference values from the fitted line. But I need to, means I don't know, any one of you have maybe I think asked or I forgot. I don't know. I can say this thing, if you are not much comfortable with the visual techniques or the visualization graphs and charts, etc., for commenting on the normality, you can go with the numeric methods also. Right here, you can see we can find there is little deviations here. Here also we can find some deviations here of the differences from the fitted line. So maybe it can give one clue or one doubt in our mind whether the difference is following the normal distribution or not. So you can stick to the one of the methods which you are feeling you are most comfortable with. Going down, this is we do not need to report. Come down. Now you can check. Here, if I talk about the box plot at the lower whisker, beyond the lower whisker, you can find there is no circle or asterisk coming. Means at the lower side there is no outlier values available. But at the upper side, because beyond the upper whisker we can find certain circles, 230, 264, and 90. These are the three respondents or three employees or three students whose scores are indicating us, or the reference of those students are indicating us the outliers. But if you can recall, I told you that circles are insignificant outliers. Asterisks, that is a star kind of symbol, those are the significant outliers. Means if we are keeping them in the data, still it will not impact your results, right? So this way we have understood the assumptions of paired samples t-test. I hope no doubt till now. Shall I proceed for performing of the paired samples t-test now?
Yes.
Yes, ma'am.
Yeah. So go to the analyze, then compare means, and then paired samples t-test. Select this. So the dialog box will appear like this. Here you can shift grade 1 into the variable 1 using the arrow key, grade 2 into the variable 2 using the arrow key. It is not necessary always you can use the arrow key. Even if you wish, you can drag and drop also. At whatever place you want to drop your variable, that also you can do, right? Then
Yes, ma'am.
now options I'll show you. It is showing you the confidence interval percentage. By default it is 95, so we can say the level of significance is 5%, right? Click, press on the continue. Nothing you need to do except shifting your variables here. I'll click on OK to get the output. I hope everyone is getting the output.
Yes, ma'am.
Yes, ma'am.
Yes. Shall I proceed with the interpretation part?
Yes,
Yes.
ma'am.
ma'am.
Yes. So you can check when I talk about the paired sample t-test, where you can find the first table, which is the statistics table. There you can see the mean grade or the mean value of the grade 1 is 6.01. For grade 2, it is 7.19.